Hello class, once again welcome to your online class. Today we will be starting a new chapter matrix which is related to the previous chapter determinant we have studied. Okay, so matrix, the basic concept you have already learned in class 10 also, how the addition of matrix, the subtraction and the multiplication of matrix is carried out. So here we will just discuss some of the important points that is in your ISC syllabus. So coming to the matrix multiplication, so which you have already learned in class 10. So the two matrices can be multiplied only in one condition, when the row of the first matrix is equal to the column of the second matrix, and the order of the matrix that is obtained on multiplying the two matrices whose order is I cross j and j cross n will be simply equals to I cross n. Okay, so that is the rule for the matrix multiplication. Just remember that the column of the first matrix must be equal to the row of the number of rows in the second matrix. The second thing is the transpose of a matrix. So what is a transpose of a matrix? So if you interchange the row and the column, suppose if I have a matrix A whose column and whose row and column is I and j. Okay, so the transpose of the matrix, so I represent it as A transpose. Ij will be equals to A j into I. That means you interchange the row and the column. Like for example, if you have a matrix A, B, C, D. Okay, if you transpose it, what will happen? So the column I will make it as row, like A, C, B and D. Okay, so interchanging the row and column of the matrix is known as a transpose of a matrix. Then comes the symmetric and a skew symmetric matrix. So the symmetric matrix is the one in which the matrix is equal to its transpose. Suppose if I have a matrix, like the matrix is said to be a symmetric matrix if A I j is equals to A j I. Okay, so if you interchange the row and the column of the given matrix, the matrix obtained will be same as the original matrix, and the matrix is said to be a skew symmetric matrix if it is symmetrical along its leading diagonal. Okay, like, or we can also say that in this case the A I j, that means the transpose of the matrix will be equals to negative of j into I. Okay, so the transpose of the given matrix is the negative of the given matrix itself. In such cases it is said to be a skew symmetric matrix. For example, matrix like if I write 1 2 3, okay, 1 2 3 5, and then here if I write 3, if I write 7 1 1. So if this matrix, so what will happen if I interchange the row and the column? So if A is equals to the given matrix, if I find A transpose, then what will be the A transpose? I will just interchange the row as a column and column as a row. Like I'll write this one as a row now. So it will be 1 2 3. The second is 2 5 and 1, and the third one will be, it will be 3 1 and 7. So if you see, the matrix obtained by the interchanging the row and the column is same as the given matrix itself. So therefore the matrix A is said to be a symmetric matrix. Okay, so now coming to the skew symmetric matrix, also remember that in a skew symmetric matrix the leading diagonal always remains the 0. Like I have the leading diagonal here means all of these three remains 0. Okay, if I write A B minus A minus B C and minus C. Okay, so if A is a given matrix in this form, so if I transpose it, what will I get? I'll get A transpose will be equals to, like I'll write this one as now 0 minus A minus B, and then again A 0 minus C, and finally B C and 0. Now if I take minus common from this matrix, I'll get this one as, so 0 minus A minus B, A 0 minus C, and B C and 0. So we see that this matrix is equal to the original matrix itself. So such kind of matrix is said to be the skew symmetric matrix. Now one of the important property related to this symmetric and skew symmetric matrix is, so if A is the given matrix, okay, so then the symmetric matrix is given as, it is A plus the A plus the A transpose. Okay, so this gives me the symmetric matrix, and the skew symmetric matrix is given as A minus the A transpose. Okay, so in that way we can easily find the symmetric and a skew symmetric of a given matrix following this simple formula. That means if you are asked to find the symmetric matrix, simply find the transpose of the given matrix and add the two matrices. So you will get the symmetric matrix, and skew symmetric matrix is the difference of the given matrix and its transpose. And also the second property or the second use of the symmetric matrix and a skew symmetric matrix is, every matrix can be expressed as the sum of the symmetric and a skew symmetric matrix. Suppose if A is the given matrix, then A can be like, it can be expressed as the sum of the symmetric, half of A plus A transpose plus half of A minus A transpose. Okay, so using this formula we can easily express the given matrix as the sum of its symmetric and skew symmetric matrix. So we'll do one question based on this symmetric and skew symmetric matrix, and the rest you can try it yourself. So here is one question that I have taken from your book, which tells us express the given matrix, that is 3, minus 4, 1 and minus 1 as the sum of symmetric and skew symmetric matrix. So from the previous knowledge we can find the symmetric part and the skew symmetric part of the given matrix. So to find that, first we find the transpose of this matrix. So let A is equals to, so I write let the A is equals to 3, 1, minus 4 and minus 1. So therefore A transpose will be equals to, simply interchanging the row, so 3, 1, minus 4 and minus 1. Okay, so after this I find the symmetric part. So symmetric part of the matrix will be, simply it will be A plus A transpose. So which will be equals to, A is 3, minus 4, 1, minus 1 plus 3, 1, minus 4, minus 1. So you already know the addition of matrix. So what I will do, I will add the corresponding elements of the two matrices. So 3 plus 3 gives me 6, minus 4 plus 1 gives me minus 3, 1 minus 4 gives me minus 3, and finally minus 1 gives me minus 2. Okay, so this is the symmetric part, and now I find the skew symmetric. So skew symmetric part is given by A minus A transpose. Okay, so which will be equals to A, here I have 3, minus 4, 1, minus 1. So minus 3, 1, minus 4 and minus 1. So on subtracting, what do I get? I get 3 minus 3 gives me 0. Okay, then minus 4 minus 1 give me minus 5. 1 minus into minus is plus, so 1 plus 4 is 5, and minus into minus it is plus, so minus 1 plus 1 it gives me 0. Okay, so we have now the matrix is expressed as equal to half of the symmetric part, that is A plus A transpose, and then the second one is plus half of A minus A transpose. Okay, so just substitute the value, you will get half into, now A into A transpose, it is 6, minus 3 and minus 2, and the second part is half into A minus A transpose is 0, minus 5 and 0. Okay, so what will I do now? Now I will multiply each of the element with half. So I get 6 by 2 minus 3 by 2 minus 3 by 2 minus 2 by 2, and then plus here I will get 0 minus 5 by 2 and then 0. So now on adding this element, what will I get? I will get Now 6 by 2 is 3, 3 minus 3 by 2, and then again minus 3 by 2, minus 2 divided by 2 is minus 1. And on the other side it's simply 0 minus 5 by 2, 5 by 2, and then 0. So what we'll do, I'll add the corresponding element. 2 matrix will give me 3 plus 0 gives me 3. So minus 3 by 2 minus 5 by 2. How much I'll get? I'll get it as minus 4. Let's say minus 3 by 2 minus 5 by 2. So this gives me 2 divided by minus 8. So it gives me minus 4. So here I'll be having minus 4. Now this element, so it is 2 is the LCM, minus 3 plus 5. So it gives me 2 divided by 2, which is 1, and finally minus 1 plus 0 is minus 1. Okay, so which is equals to the given matrix. Okay, so this is how we solve this kind of question, where it says that the given matrix, expressing the given matrix by its the symmetric part and the skew symmetric part.